Hello students, welcome to the session. In this video, let us discuss the problems given in the assignment on module 3, that is probability, distribution and random variables. And in the assignment, hope we have to discuss 7 problems. Let us discuss one by one. The first problem says a box contains 12 balls, of which 3 are white and 9 are red. A sample of 3 balls is selected at random from the box, and let X denote the number of white balls in the uh, sample. Find the distribution of X and also determine mean and standard deviation of the distribution. First, let us analyze the problem. And we have the content of the container is there are 3 white balls and 9 red balls. Totally there are 12 balls, and a sample of 3 balls is drawn at random. And now let us define the random variable X as number of white balls drawn in the sample. Therefore a sample consists of 3 balls, and X denotes the number of white balls in the drawn sample. Suppose when we draw 3 balls, if all the 3 balls are of red color, then there are no white balls in the sample. In that case, the variable X takes the value 0. Suppose in a sample there is one white and 2 red. In that case, the random variable X takes the value 1, as it represents number of white balls in the sample. Suppose there are 2 white and 1 red. In that case, X takes the value 2. Suppose all the 3 white balls are there in the sample, then the random variable X takes the value 3. Therefore, in this case, the random variable X, what you have defined as number of white balls drawn in the sample, it takes namely 4 values, namely 0, 1, 2, 3. Now, first they asked to find the probability distribution. First, let us recall the concept of probability distribution. Probability distribution means it is the systematic representation of the values taken by the random variable with corresponding probabilities. Now already we have got the values taken by the random variables, namely 0, 1, 2, 3. And now we are required to find the corresponding probability. Means we have to find the probability that X takes the value 0, probability that X takes the value 1, probability that X takes the value 2, probability that X takes the value 3. Now, generally, probability of any event is given by the rule M by N, where M represents number of favorable cases and N represents total number of equally likely cases. Now, here first let us find the total number of equally likely cases, means total number of equal possible cases. Out of 12 balls, any 3 balls can be drawn in 12 C3 ways. That means in this case N, that is total number of possibilities are given by 12 C3. That's why for each case in the denominator we have written 12 C3, that is total number of equally likely cases. In the first case, you have to find the probability that X equals to 0. Probability that X equals to 0 means probability that there is no white ball in the sample. Means out of 12 balls we are drawing 3, and out of 3 no white ball means all the 3 must be red. That's why the possibility of drawing 3 red marbles, that is in the first case M is given by, that is a 3C0, means out of 3 no white, that is 3C0, and out of 9 red 3 to be drawn, that is 9C3. Probability of X equal to 0 means it is a probability that no white ball is in the selected sample of 3 balls. Therefore, it is given by M by N, and N for all the cases is 12C3. And in the first case, all the 3 must be red. That's why it is 9C3. Out of 9, 3 can be selected in 9C3 ways. And since there is no white ball, that's why it is 3C0. Now it is probability of X equals to 1, means probability that there is a one white ball in the sample. Therefore, one white means other two must be red. Therefore, both must happen simultaneously. Therefore, out of 3 white balls, any one can be selected in 3C1 ways. Into means at the same time, out of 9 red balls, 2 balls can be selected in 9C2 ways. Therefore, this is a property of X equals to 1, means there is one white ball in the sample. If I take X equals to 2, that is probability that X equals to means probability that a sample consists of 2 white balls. Out of 3, 2 can be selected in 3C2. Out of 3, 2 white means 1 must be red. Therefore, out of 9 red, one red can be selected in 9C1 ways. Similarly, when we go for the last, that is plot of x equals to 3 means all the three balls in the samples must be white. Out of 3 white can be drawn in 3C3 into out of 9 red, no no red ball must be there, therefore it is 9C0. Therefore, these will give the probability of selecting no white, one white, two white, and three white balls in the samples. That's why now this represents the corresponding probability that the variable x takes the value 0, x takes the value 1, x takes the value 2, x takes the value 3. Therefore, it is 0, 1, 2, 3. These are the possible values taken by the variable. And now once you calculate this value, that gives you 84 divided by 20. That is nothing but 21 by 55. When we calculate this value, it will give 108 by 220. When we calculate this value, it will give 27 divided by 220. And when you calculate this one, this gives you 1 divided by 220. Therefore, once you sum all these parties, it will be equals to 1. Therefore, this represents the probability distribution of number of white balls drawn in the sample. Therefore, here x takes the value 0, 1, 2, 3, and this represents their corresponding probabilities. Since along with the probability distribution, they asked mean and variance also. Now, first let us find some calculations with respect to probability distribution. Now, let us calculate x into p of x. That will give you this into this, this into this, this into this, this into this. The total seems to be 160 divided by 220. And let us calculate x square into p of x. Already x into p of x is calculated. Multiply that one by x. This into this is this into this, that is this into this, that is this into this, that is this. Therefore, once you add this, that will give you, that is 225 divided by 220. And we know mean is given by expected value of x, that is summation or total of x into p of x. In this case, summation or total of x into p of x is 165 divided by 220, that is 0.75. Now first let us calculate expected value of x square, that is given by summation of x square into p of x, that is nothing but 225 divided by 220. And we know variance is given by expected value of x square minus expected value of x whole square. And we know expected value of x square is 225 divided by 220 minus expected value of x is, that is 165 divided by 220. We are required to take the square for that. This by this will give you this, and minus, and this this is nothing but 0.75 square, and that will be equals to, that is actually it is 0.75. I have to take, I have taken 0.7, therefore let us take it as 0.75 square. Its value seems to be 0.4605. That will be the variance, but the standard deviation, it is given by square root of variance. That is given by square root of this seems to be 0.6786. That will be the required standard deviation. That will be the solution for the first problem of the assignment. Now let us go to the second problem, and it says a random variable x has the PDF f of x equal to k into e raised to minus 2x whenever x is greater than or equal to 0, and is 0 whenever x is less than or equal to 0. Now the question is like this. First one, find the value of k. Second one, find the probability that x lies between 1 and 3. Next one is x is greater than 0.5. Next one is mean and standard deviation. Now first we have to find the constant k. Now for a valid probability distribution, we have integration of f of x dx equals to 1 over the range of the random variable. In this case, the random variable takes the value greater than 0, and for other case its value is 0. That's why discarding this, if you take, it is 0 2 for any random variable, upper limit is always infinity. Therefore x varies from 0 to infinity. F of x is k into e raised to minus 2x into dx, and this becomes k is a constant. If you integrate this, it will be e raised to minus 2x divided by minus 2. And once you take the upper limit, it is k by minus 2 kept as it is. If you take the upper limit, e raised to minus infinity is 0, and e raised to 0 is 1. If you multiply, that becomes k by 2 equal to 1. Accordingly, k value is 2. And now once you substitute this value of k in the given probability density function, it gives you f of x equals to 2 e raised to minus 2x whenever x is greater than or equal to 0. Second one, it is 0 whenever x is less than or equal to 0. That will be the value of k. The second one, we are required to find probability that x lies between 1 and 3. Therefore, it is a continuous, therefore it is integration, lower limit is 1, upper limit is 3, fx into dx, fx is this, If you integrate, 2 will get cancelled. This is minus. If you take the upper limit, e raised to minus 6. If you take the lower limit, it is e raised to minus 2. That gives you e raised to minus 2 minus e raised to minus 6. That will be 0.1329. The next one is product of x is greater than zero point 0.5. Therefore, that gives you zero point 0.5 to infinity, because x is greater than zero point 0.5 means it is a continuous variable. That's why I have to take the integration, and lower limit is zero point 0.5, and for any random variable upper limit is infinity. And if you integrate again, this 2 will get cancels. If you take the upper limit, e raised to minus infinity is 0. If you take the lower limit, that is e raised to 2 into zero point 0.5 is 1, and finally it is e raised to minus 1, its value is 0.3679. Third one is expected value of x, that is given by, for a continuous random variable, integration over r x into fx into dx, x as it is, then it is f of x into dx. Therefore 2 is a constant, I'll take it outside. Then it is 0 to infinity e raised to minus 2x, then x can be written as x raised to 2 minus 1 into dx. And from gamma integral we have one standard result, that is integration of 0 to infinity e raised to minus ax x raised to n minus 1 into dx is given by gamma n divided by e raised to n. And also, if n is a positive integer, n gamma n can be written as n minus 1 factorial. That's why once you compare this integral with this, we can write this one as gamma 2 divided by e raised to n, means e is 2, that is 2 raised to 2 we can write. Therefore gamma 2 is 1 factorial, 2 raised to 2 is 4. Therefore that gives you 1 by 2. The mean value for the distribution is 1 by 2. Now let us calculate one more expected value of x square, that is given by integration over r x square into f of x into dx, that gives you 0 to infinity x square, and f of x is 2 into e raised to minus 2x into dx. 2 is outside, that is e raised to minus 2x into x raised to 3 minus 1 into dx. Therefore it is 2 as it is, and this is gamma 3 divided by 2 raised to 3, because when you compare this one, therefore with this, what we have taken as a standard one from gamma functions, we can write that one as gamma 3 divided by 2 raised to 3. Gamma 3 means 2 factorial, because of this, that is gamma n is n minus 1 factorial. 2 raised to 1, 2 is get cancels, that becomes 2 raised to 2, and 2 factorial is 2, 2 raised to 2 is 4, again it leaves as 1 by 2. Therefore expected value of x square is also 1 by 2. Standard deviation is square root of variance, and that is given by square root of expected value of x square minus expected value of x whole square. That when equal to 1 by 2 times minus 1 by 2 whole square, that is 0.5 minus 0.25, that is square root of 0.25 is 0.5. Therefore mean is 0.5 and standard deviation is also 0.5. That will be the value for the standard deviation for the given problem. That is all about the second problem. Now let us concentrate on the third problem. It is given that the problem statement is like this. It was found that 10% of the boys in a certain class were suffering from short sight. What is the probability that a random sample of 5 boys will contain no boy suffering from short sight and exactly 1 boy suffering from short sight, and not more than 4 boys suffering from short sight? Once we look at the problem and the requirement, the probability is regarding with respect to number of boys suffering from short sight. In all the cases, the probability is with respect to number of boys suffering from the short sight. In the first case, no boy. In the second case, 1 boy. In the third case, not more than 4 boys. That's why now let us define the variable x as number of boys in the sample suffering from the short sight. And now number of boys in the sample, they have taken the sample of 5 boys, and p is the probability that a boy is suffering from short sight, and that is given by 10%. It is given in the problem. 10% means 10 by 100, that is 0.1, and q is 1 minus p, that is 0.9 bigger. Therefore in this case x follows binomial with n equal to 5 and p equal to 0.1. Now why we have taken this, that makes a lot of sense. Why it is binomial? Once you look at the variable, now what is n? N is 5, that is finite, the first case. Second one is, if you take any boy, the possibilities are he is suffering from short sight and he will not suffering from short sight. There are the two cases for every boy. Therefore, every student will boy is categorized into two cases. That is the second one. And the probability of having a short sight for all the boys is same. That is 10%. That is 0.5. Therefore, all the three conditions of binomial probability distribution fulfills. That's why we can claim that x follows binomial with n equal to 0.5 and p equal to 0.1. Now we know the probability function of binomial distribution, that is p of x equal to n cx p raised to x into q raised to n minus x, and that one equal to 5 cx into 0.1 raised to x, 0.9 raised to 5 minus x, where x takes the value 0, 1, 2, 3 up to 5. And let us consider the first one. Probability of no pi suffering from the short side means the variable x takes the value 0. That is p of 0. Let us go to the probability function or the what you have written as p of x and take x equal to 0 there. We get it as this is 1, this is 1, 0.9 raised to 5, that is 0.5905. That is the first one. Exactly 1 by suffering from short side means the x variable x takes the value 1. Therefore, we can take x equals to 1, that is p of 1. That is 5c1, 0.1 raised to 1, 0.9 raised to 4, that is 0.3281. The third one, probability of not more than 4 boys suffering from short sight means not more than means x must be less than or equal to 4. Therefore, less than or equal to 4 means you have to consider x equal to 0, 1, 2, 3, 4. Means near about 5 probabilities you have to consider if you go like this, if you take the permissible value. Once you think of its complement, that is, we know the complement rule as part of equal to 1 minus part of its complement, that one equal to 1 minus part of x is greater than 4. Greater than 4 means only one value, part of x equals to 5. That is 1 minus. Let us take x equal to 5 in this case. 5c5 is 1, 0.1 raised to 5, and this is 0.9 raised to 0. Once you simplify, that is almost 1 billion. That will be the problem on binomial. That is the third one. Now let us come for the fourth one, and the question is like this. A car hire firm has two cars which it hires out day by day. The demand for the car on each day is distributed as a Poisson distribution with the mean 1.5. Therefore, calculate the probability that on a certain randomly chosen day, neither car is used, some demand is refused. Now here, the requirement is probability of something at something is how many cars are used on a daily basis. That's why now let us define the variable x in this fashion. That is, x represents demand for the car on a day, and they have given demand is a Poisson variant with mean, and mean of the Poisson is lambda, that is 1.5 they are given. This implies the probability function of Poisson is given by e raised to minus lambda, lambda raised to x divided by x factorial, and that is given by e raised to, and lambda is 1.5, that is e raised to minus 1.5, 1.5 raised to x divided by x factorial, where x takes the value 0, 1 to up to infinity. First one, probability of neither car is used means there is no demand on that particular day. Therefore, no demand for the car on a day. That means x equals to 0 there. Neither car is used means definitely car will be used whenever there is a demand. Neither car will be used means there is no demand for the car on that day. Therefore, in that case, x equals to 0 means p of 0. Taking x equal to 0 in the probability function, we get it as e raised to minus 1.5. Its value is 0.2231. Next, one some demand is refused. Some demand is refused. First of all, let us understand when the demand is going to be refused. First, once you look at the statement of the problem, they have given a car hire firm has two cars. Maximum that firm can give or supply two cars on a day. Suppose if there is a demand of more than two cars on the particular day, then only the demand may be refused. That's why here we can conclude that the demand is refused, okay, only when, okay, here the demand is refused only when there is a demand, means the demand is refused only when the demand for the cars is more than two on a day, because at the most the firm can supply two cars. If there is more than two as a demand, definitely the demands are going to be rejected, some demands. In that case, that is property of x is greater than 2. Greater than 2 means 2, 3 and so on up to infinity. It cannot be possible to go directly. Let us use the complement rule, that is 1 minus property of x is less than or equal to 2. Less than or equal to 2 means the permissible values are 0, 1, 2. That is 1 minus, that is p of 0 plus p of 1 plus p of 2. That is 1 minus, and this one means in order to calculate this p of 0, p of 1, p of 2, we have to approach this function and we have to take x equal to 0, 1, 2. Every time I can take e raised to minus 1.5 as our common term. Then if you take x equal to 0, you'll get 1. If you take x equals to 1, you'll get this. X equal to 2, you'll get this. And the simplification of this one, let's 1 minus 0.8088, and the final value is 0.1912. That is the probability that there is a refused, means there is a demand is refused on a certain day. It happens only when there is a demand for more than 2 cars on a particular day. That is a problem on Poisson. Now let us concentrate on the fifth problem. At a certain city bus stop, on an average, 3 buses arrive at a hour per hour. Assuming that the time between successive arrivals is an exponential distribution, find the probability that the time between the arrival of successive buses is first one less than 10 minutes and the second one at least 30 minutes. And see here, one thing we have to note, the information is given with respect to the number of buses arriving in a bus stop in an hour per hour, but the requirement is regarding the time factor. That's why when there are 3 buses arriving per hour to a bus stop, that means on an average 1 hour means 60 minutes. 60 divided by 3 means 20. On an average, there will be a 20 minutes gap between 2 buses which are going to come at the bus stop. That's why if you take mean as 3, it's wrong. That's why the time you have to take into account as an exponential, not the number of buses arriving at the bus stop. That's why first let us consider that one, that here let us say x, the time between the successive arrivals of the buses, and they are given on an average 3 buses arrive in an hour. That means on an average the time between 2 successive arrivals is 20 minutes, because 60 divided by 3 is 20 minutes. They are given that as time between successive arrivals is exponential with mean, that is average equal to 20, but we have mean of the exponential as 1 by theta. That means 1 by theta equal to 20. That means theta equals to 1 by 20. And the probability density function of exponential is f of x equal to theta into e raised to minus theta x. That will be 1 by 20 into e raised to minus x by 20 whenever x lies between 0 and infinity. Now let us see the first requirement, that probability that time between successive arrivals between buses is less than 10 minutes. That means that x that we have defined as time between successive arrivals, that x must be less than 10. That means this 10 will act as the upper limit for the variable, and we know the lower limit for the variable is 0 fx into dx, because it's a continuous variable. That's why we have to go with an integration. That is integration from 0 to 20. Okay, 1 by 20, that is f of x are substituted. Once we integrate, this 1 by 20 will get cancelled. 0 to 10 you have to go for, this is minus, and I will write as it is. If you take the upper limit, that becomes e raised to minus 0.5 minus lower limit 0, that is e raised to 0. Once you take e raised to 0 is 1, along with the negative side, that becomes 1 minus e raised to minus 0.5, that gives you 0.3934. The second one, probability that the time between successive arrivals of the buses is at least 30 minutes. At least 30 minutes means 30 or more minutes. That is part of x is greater than, because you have taken the time between successive arrivals as x. That is at least means x is greater than or equal to 30. In that case, 30 will act as a lower limit, and for the variable upper limit is infinity, that is 30 to infinity f of x into dx. Once we integrate this, this is minus sign, and once you take upper limit e raised to 0 and minus, when you take 30, that becomes 1.5, minus of minus becomes 5, that is e raised to minus 1.5. that is 0.2231. That is all about the probability that the time between two successive arrivals is, that is 0.2231. At least 30 minutes is 0.2231. 0.2231. Okay, now let us go to the next problem, that is sixth one, and it is like this. 200 students appear an examination. The distribution of marks obtained is assumed to be normal with mean 30 and standard deviation 6.25. Find how many students are expected to score, first one between 20 and 40, second one less than 35 marks. And first, they are given the information about marks scored by the students. That's why let us say x as the variable x as marks obtained by the students in an examination. They are given marks scored is normal with the mean 30 and standard deviation 6.25, and n is number of students appear in an exam, that is 200. They are given capital N. Now standard normal is given by x minus mean by standard deviation, that is x minus 30 divided by 6.25. And since there's number of students, as we know, the frequency is given by total frequency into corresponding probability. That's why first let us find the probability that the student scores between 20 and 40 marks. Therefore, consider the student scores between 20 and 40 marks. That is nothing but x lies between 20 and 40. Now converting this one into standard normal, we can write 30 of 20 minus 30 divided by 6.25 is less than x minus 30 divided by 6.25 is less than 40 minus 30 divided by 6.25, and this gives you minus 1.6, and this gives you that is plus 1.6, and this is nothing but the standard normal variable z. And once you plot this diagram, as we know that 1.6 is at the same distance from the 0 as that of minus 1.6. That's why that will be nothing but 2 times, both areas are same. That's why we can say that 2 times the area from 0 to 1.6 because of the symmetry. From the standard normal table, area from 0 to 1.6 is 0.4452, and once you multiply this one by 2, it will be 0.8904, and that's why we want the frequency rather than priority, but frequencies are given by f of x equal to n into p of x. That's why we say that number of students scoring marks between 20 and 40 equals to capital N into probability of that situation. Capital N is 200, and the probability that x lies between 20 and 40 is given by 0.8904. Once you calculate this one, that will be 178. The second one, again we have to consider here number of students scoring less than 35 marks, but first let us consider probability that a student scores less than 35. That means probability of x is less than 35. Again, converting the normal to standard normal, we can write like this, subtracting mean dividing by standard deviation, and that gives us that is less than 0.8. Therefore, this is less than 0.8 means probability of area from minus infinity to 0, and the 0.8 is somewhere here. Less than means below that. This entire probability we want. Therefore, this area can be calculated from area that left half covers, that is minus infinity to 0 plus 0 to 0.8, that we have written here. Area from minus infinity to 0, that is left half, that is 0.5, and area from 0 to 0.8 is 0.2881. This will be 0.7881. This is the probability that the student scores less than 35. But we want number of such students, that is given by multiplying this probability by capital N, that is 200. It is given by that is almost 158. That will be the requirement. Now in the last problem, we can check like this. The statement is like this: in a normal distribution, 7% of the items are under 35 and 19% of the are under 63. Find mean and standard deviation. Let us define the variable x as value of the variable that you have taken, and we don't know what is the mean and standard deviation. We are required to find those. So let us say, because they are given in a normal distribution, that means x follows normal. Say mean is mu and standard deviation is sigma. And standard normal variable is given by value of the variable minus its mean divided by standard deviation. And they are given probability of x is less than 35 is 7%, means 7% of the items are less than 35 means probability that x is less than 35 is 7%, and probability of x is less than 63 equals to 19%. That means 19% of the items are under 63, 7% are under 35, okay, and 19% are under 63, as it is evident from the statement of the problem. 7% are under 35 and 19% are under 63. Based on that, we can write this one. Okay, now let us convert this one into standard normal, that we can write like this: subtract mean divided by standard deviation. 7% means 0.07, 19% means 0.19. And let us join this one as Z1 and let us join this one as Z2. Now plot the graph for this and see here, it is very evident that probability of Z is less than Z1 is 0.7. Then the question is where you have to choose Z1. Anywhere we can choose, but this probability should be satisfied. Under worst case, let us take Z1 at the center. If I take Z1 at the center, below that we get 0.5 because left of course 0.5. But we want a 0.07. Okay, it is less than 0.5. That's why our Z1 should lies left of 0. That's why Z1. And this area I'm going to mark it as 0.07. That means the area between 0 and Z1 is 0.4. And again, I can take Z2 anywhere with respect to the second one. If I take in the worst case at center, then below that we get 5%, that is sorry, 50%, that is 0.5, but here it is only 0.19, that is less than 0.5. That's why I still have to move to the left. So somewhere I mark it as Z2 and I'll show this area is 0.19. And now between these two, 0 and Z2 is 0.31 because 0.5 minus 0.19, that is 0.31. In the same fashion, left of course is 0.5 minus this, that will give you 0.43 here. Now we can write that is probability between 0 and Z1 is 0.43 and a probability between 0 and Z2 is 0.31. Now let us go to the standard normal table and let us find for what value of Z1 the area is 0.43 and for what value of Z2 the area is 0.31. From the standard normal table, we can find that for approximately area up to for point z equal to 0.15 is 0.4332. That's why for 0.43 I can take Z1 as 1.5 and area from 0 to okay, that is 0.9 is 3159, that is 31 is there. That's why I can take approximately that Z2 is 0.9. Now these Z1 and Z2 both are attached with a negative sign because it is evident that both Z1 and Z2 lies left of 0. When they lies left of 0, they should attach by negative sign. Therefore negative sign are attached. And now let us substitute the values Z1 and Z2. What you have denoted here, this one you have taken as Z2, this one you have taken it as Z1, sorry, Z1, and this one as Z2. By substituting this, we are going to get this one. And once you simplify, it is mu minus 1.5 to sigma equal to 35. And once you simplify this one, mu minus 0.9 sigma equals to 63. By solving these two using calculator, we will find mu equal to 105 and sigma equals to 46.47. This is the way how we can go for finding the values of mean and sigma using the given information. And in this video we have discussed the solutions for all the assignment problems which are given on module 3, and the module 3 is on random variables and probability distribution. Thank you.